The product rule. Objectives. By the end of this lesson, you should be able to recognize when you need to apply the product rule, apply the product rule to find a derivative. So the general idea is, right, we want to take a derivative of two functions to be multiplied. So how do we do that? Well, product rule. So if f and g are differentiable functions, then the key things that they have to be functions. We'll talk more about that in a second though. Then f and g is differentiable. So f times g prime equals f, notice that f is left alone, times g prime plus g times f prime. So in general, I always like to say these things in words. It's the first one times the derivative of the second plus the second times the derivative of the first. That's all it is. You take the derivative of one of them, times it by the other, and then flip it, plus the other one times the first one left alone. So that's product rule. So when we're multiplying two things, that's the thing we have to follow. Now, again, notice when we're multiplying two functions. So if I give you like 3 times e to the x, you could use the product rule on this, but you don't need to. This is just a constant times a number. You just take the derivative of this one and times it by 3. But if I give you e to the x times x squared, or just like x squared e to the x, this is a product rule because it's a function times a function. So even this, you have to use this formula. Just take the derivative of one of them, leave the other one left alone, and switch it. Keep in mind, right? Cannot stress this enough. People start getting lazy. They take the derivative of this. They just take the derivative of each one. That's not how it's done. This is not 2x e to the x, right? It's a product rule. We have to follow the formula. And since we're in IB, we actually get the formula. And this is how it's written in your formula sheet. So this is how you get to use it. Now, notice a lot of people get freaked out when they see this dy dx, this d over dx. That's just derivative. So over here, they're saying, hey, you have two functions. One of them is du, one of them is v. And then it says, right, the derivative of dy dx, so the derivative equals du. dv dx, people get scared by seeing that. That's just v prime, right? That's the second one prime. Then over here you have v times du dx. du dx is just u prime. That's all it is. This is the exact same thing as saying u times v prime plus v times u prime, right? So it's derivative of one of them times the other plus the derivative of the first times the second, right? Like it's derivative of one of them and then switch it, blah, 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 blah. That's product rule. So actually, let's actually do it to the thing I had over there. So I see this, I'm like, oh, I'm multiplying two functions. I got to use the product rule. So if you want, we can just follow this formula, right? It's u v prime plus v u prime. So our u is x squared, right? It's the first one there. Our v is e to the x. U prime, take the derivative of this, that would be 2x. And then v prime, take the derivative of this, would be e to the x. And you just kind of plug it in. So u is x squared. V prime is e to the x. Plus v, which is e, right? Plus the second one left alone. Times the derivative of the other one, 2x. And that's the derivative. Right, so that's the formula. Most of the time we don't need the formula. It's like, oh, take the derivative of one of them times the other plus switch it. Like that's all you have to go. Take the derivative of one times the other plus the other way around. So let's do some more examples. Again, notice I'm multiplying two things, right? So let's do it the other way. So this is our u and our v. So if you want, you can stretch it out, but we're just going to let's take the derivative of one of them. Let's take the derivative of u. So that would be negative 2x. Right, that goes away. Bring that down, subtract one off. Leave this one alone, 2x minus 1, plus, switch it now, let's take the derivative of this one, 2x, right, the 1 goes away, and then leave the u alone. Most of the time you just leave it like that, you're done, but if you want, you can simplify it also. Negative 4x squared plus 2x, plus, you can distribute this, 2x minus 2x cubed, then we can make it pretty. Negative 2x cubed minus 4x squared plus 4x. But again, IB, unless they specifically tell you to put it in a certain way, this is fine. And then if they say, oh, put it in this form, then you have to get that far. Let's move on to the next one. So look at this one. Take the derivative of x dx, right? Oh, that's two functions. Don't let the x scare you, right? It's my u, it's my v. Let's take the derivative of the first one, 1. Leave the second one left alone, gx. Right? The derivative of x is 1. Leave the second one alone, gx. Then we switch it, take the derivative of the second. Well, the derivative of gx is this going to be g prime x. Then times the other one left alone, x. That's it. That's all you could do. I mean, you can make it a little prettier if you want, but that's it. Right, same thing down here. Don't get freaked out by the fact that there's no numbers. It's the same concept. Oh, we're multiplying two functions together. It's the derivative of 1 times the other left alone, plus switch it, derivative of the second times the first left alone. That's always I do it. I always do derivative of the first. For me to like, oh, if it's a u and v, I just do derivative of the first one. So I go like u prime times the second plus switch it v prime u. Right? It doesn't matter. You're adding, so it doesn't matter which one goes first. That's just always the way I preferred it. And then look at this last one we're doing on this lesson, this little mini lesson. Suppose that f prime of 1 equals 0 and suppose that f of 1 equals 0 and f prime of 1 equals 2. Find g1 assuming that f g prime of 1 equals 10. So I said that terribly, but the idea is, right, they give you this information, they want you to, and they're letting you know that f prime of g, f times g prime of 1 is 10. So when you plug in 1 into the derivative, it equals 10. So let's do that, right? Let's find out let's do this. What is f of g prime of 1? Well, I know it equals 10, but let's expand this out, right? So it's derivative of the first one, f prime of 1 times the second left alone, g of 1, plus derivative of the second one, g prime of 1 times the first one left alone, f of 1. That should equal 10. Now let's look at what we have here. Right, just roll out the formula from, let's roll out the product rule. Now they tell me f of 1 is 0. So right here, this is 0. F prime of 1 is 2. So right here, that's 2. And then I want to find g1, just like my x. Let's put an x here because I'm looking for that. I have no idea what this is. This is still g prime of 1. I have no idea what that is. But I know if you multiply it by 0, it's going to go away. So 0. This is just 2x, or 2 times g1 equals 10. So 2x equals 10. So x equals 5. So g of 1 equals 5. Actually, before I go, let's do one more example. I'm not sure if we've done one of these, so I want to make sure I hit it before I go. So let's make one on the spot. Let's say f of x equals ax squared plus b. And then let's say a and b are constants. Now, so let's say f of 1 equals 4. And then f prime of, let's say, 2 equals 8. I'm just making stuff up. So how would you go across from like this? Well, let's just see what everything says, right? First thing they tell us is f of 1 equals 4. So that means, here's my function. If I plug in 1, it's going to equal 4. So if I plug in 1, I'm going to get a times 1 squared plus b. I'm going to get 4 equals a plus b. Can't do anything there. Let's move on to the next one. Right? F prime of 2 equals 8. So I got to take a derivative of this. So remember, when these are constants, you treat it like normal. So derivative of this is going to be, bring the 2 down, subtract 1 off. So 2ax. Over here, b, this goes away. It's a constant. So my derivative is that. Now with my plug in 2, it should equal 8. So plug in 2 for x. It should equal 8. I'm going to get a equals 4x. Or x equals 2. 4a. X is 2, so there's only an a left. So a equals 2. So you have a equals 2. And now you can plug that into this equation. And get 4 equals 2 plus 2. 2 plus b. Subtract that. B equals 2 also. Right, so I just want to go over one of those real quick, right? If you have variable constants, it's the same idea, right? Nothing changes. You just take the derivative, and that's a constant. It's like a 5, it goes away. That's like a 3. Bring the 2 down, multiply it, subtract 1 off. So even if you have variable constants, nothing changes. So that's it. We're done.